Chapter 8 Risk and Return. Risk is defined as the possibility that actual cash flows returns will be different from forecasted cash flows returns. It refers to the chance that returns from an investment will be different from those expected. Expected return can be defined as weighted average of possible rates of return, with the weight being the probabilities of occurrence. Example: there are 3 possible returns associated with investing in the Duke stock. There is a 20% chance that the investment return is 10%, a 60% chance that the investment return is 18%, and a 20% chance that the investment return is 26%. The expected return from investing in the Duke stock is the weighted average of 3 possible returns, that is, the investment return of 10% times 20% probability of occurrence plus the investment return of 18% times 60% probability of occurrence plus the investment return of 26% times 20% probability of occurrence equal to 18%. Now, we may have concerns about the dispersion of possible returns from the expected return. How to measure? Standard deviation, defined as the square root of the weighted average of squared deviations of possible returns from the expected return, is used to measure the dispersion. A low standard deviation means the squared deviations of the possible returns from the expected return is small, which means all possible returns tend to be very close to the expected return. In other words, the variability is low. A high standard deviation means the squared deviation of possible returns from the expected return is large, which means all the possible returns tend to be spread out over a large range of values. In other words, the variability is high. So, we can conclude that the larger the standard deviation, the riskier is the investment. When the standard deviation is equal to 0, there is no risk. Next, let us illustrate how to apply the formula to calculate the standard deviation. Let us use Duke stock to illustrate how to apply the formula. The expected return is 18% from our earlier calculation. The deviation of the first possible investment return from the expected return is 10% minus 18% equal to negative 8%. The deviation of the second possible investment return from the expected return is 18% minus 18% equal to 0. The deviation of the third possible investment return from the expected return is 26% minus 18% equal to 8%. We next square the deviation. We then calculate the weighted average of 3 possible squared deviations, that is, the first deviation times 20% probability of occurrence plus the second squared deviation times 60% probability of occurrence plus the third squared deviation times 20% probability of occurrence equal to 25.6%. This number is termed variance. We then take a square root of the variance to obtain the standard deviation. The standard deviation we obtain is 5.06%. Now, we have the results. For Duke, the standard deviation is 5.06%. The expected return is 18%. For TI, the standard deviation is 13.91%, and the expected return is 18%. So we may conclude that TI is riskier than Duke because the standard deviation of TI is larger than the standard deviation of Duke. Now, it is safe to address the riskiness of Duke and TI by using the standard deviation because they both yield the same expected return, 18%. If they do not yield the same expected return, it is not appropriate to simply use the standard deviation to address the riskiness between these two investments. For investments with different expected returns, we propose a relative risk measure per unit reward of assumed risk to address the riskiness of the investments. The relative measure of risk per unit reward of assumed risk is calculated by the standard deviation divided by the expected return, which is also known as coefficient of variation. We see that as the coefficient of variation increases, the risk of an asset increases. For risky asset T, expected annual return is 25%. Expected annual standard deviation is 20%. For risky asset S, expected annual return is 10%. Expected annual standard deviation is 18%. Now, risky assets T and S have different expected returns. We use the relative measure of risk, coefficient of variation, to address the riskiness of these two assets. The coefficient of variation for asset T calculated by the standard deviation divided by the expected return is 0.8, less than the coefficient of variation for asset S, which is 1.8. So we can conclude that asset T is the less risky of the two investments. Now, this problem is a straightforward application of the formulas we have discussed so far, including expected return, standard deviation, and the coefficient of variation. Let me know if you have questions. Portfolio expected return is the weighted average of the expected returns from the individual securities, with the weight being the portion of funds invested in a given security within a portfolio. Assume you create a portfolio with two stocks, American Electric Power and Boeing. For this portfolio, 75% of funds is invested in American Electric Power, and the remaining 25% of funds is invested in Boeing. American Electric Power has an expected return of 12%, and Boeing has an expected return of 16%. The expected return for your portfolio consists of 75% of expected return from American Electric Power and 25% of expected return from Boeing. That is, 75% of your portfolio is going to earn you 12% expected return from American Electric Power, and 25% of your portfolio is going to earn you 16% expected return from Boeing. It is calculated as 75% times 12% plus 25% times 16% equal to 13%. Portfolio risk is not the weighted average of the risk of each individual security. This slide illustrates you that you should consider co-movement risk between securities. For a two-security portfolio, the formula for portfolio risk is provided here. We observe a new variable, correlation coefficient between the returns on security A and security B. Correlation coefficient is an index of the linear relation between two random variables. The correlation coefficient is always between +1 and -1. A correlation coefficient of +1 implies a perfect direct linear relationship between two variables. For example, high rates of return on M are always associated with high rates of return on L. A correlation coefficient of 0 implies no observable linear relationship between two variables. A correlation coefficient of -1 implies a perfect negative linear relationship between two variables. For example, high rates of return on Q are always associated with low rates of return on P. The correlation coefficient between returns on two securities has an impact on the portfolio risk. The returns from two securities are perfectly positively correlated. That is, correlation coefficient is equal to +1. Plug 1 into this formula. We arrive at this formula. We observe that the portfolio risk is the weighted average of the risk of the individual securities. Therefore, no risk reduction is achieved. The returns from two securities are zero correlated. That is, correlation coefficient is equal to 0. Plug 0 into this formula. We arrive at this formula. We observe that the portfolio risk is less than weighted average of the risk of the individual securities. In fact, as long as the correlation coefficient between the returns on two securities is less than 1, the portfolio risk is always less than the weighted average of the risk of the individual securities. That is, diversification can reduce the risk of a portfolio below the weighted average of the risk of the individual securities when the correlation coefficient between the returns on two securities is less than 1. The less positively correlated the returns from two securities, the greater the portfolio effects of risk reduction. The returns from two securities are perfectly negatively correlated. That is, correlation coefficient is equal to -1. Plug -1 into this formula. We arrive at this formula. We observe that there will always be some proportion of the securities that will result in the complete elimination of portfolio risk. That is, zero portfolio standard deviation. Important observation: as long as correlation coefficient between returns on two securities is less than +1, diversification reduces risk. In practice, your portfolio is not limited to two stocks, but may include 10, 100, 1000, and more stocks. For different combinations, you will get the graphics shown in the next slide. Each dot within the shaded area represents the risk and expected return for an individual risky security available for investment. By combining those available risky securities in different proportions, you will find that possible portfolios are represented by the whole shaded area, including the boundaries. The curved segment from A to B represents the set of efficient portfolios, also known as the efficient frontier. It is efficient in the sense that, for a given risk, it provides the highest expected return, or for a given expected return, it provides the lowest risk. rational risk-averse investors will only consider portfolios on the efficient frontier because it provides the lowest risk assumed per unit of expected return. This slide reviews the definition of efficient portfolios we just discussed in the previous slide. From our discussion of the previous slide, we know that rational risk-averse investors will only consider portfolios on the efficient frontier. Investors now are allowed to lend and borrow at the risk-free rate. When we say lend at the risk-free rate, it means you invest some money at the risk-free rate. When we say borrow at the risk-free rate, it means you borrow some money at the risk-free rate to invest in the risky portfolio you choose to hold. After introducing the risk-free lending and borrowing, investors now need to find out which risky portfolio on the efficient frontier they should choose to hold to maximize their expected returns given risk. Note: investors' investment results from allocating funds between the risk-free asset and the risky portfolio on the efficient frontier is a straight line connecting these 2 points. The straight line extends beyond the risky portfolio is achieved by borrowing at the risk-free rate to invest in the risky portfolio. Now, will investors choose A as the optimal risky portfolio to hold? The answer is no, because by moving up the efficient frontier, for example, to portfolio B, investors will yield higher expected returns given the same risk. So, investors will keep searching the optimal portfolio by moving up along with the efficient frontier. They will stop searching until they reach the tangency portfolio. Once they reach the tangency portfolio, there are no other feasible efficient portfolios for them to consider. The tangency portfolio M is the best efficient portfolio. There is no reason to hold other portfolios because you get the highest expected risk premium per unit of risk. That is, regardless the level of risk investors choose, investors get the highest expected return by mixture of portfolio M and borrowing or lending at the risk-free rate. Risk-return combinations between risk-free rate and portfolio M can be achieved by investing some portion of funds in the risk-free security and the remainder of funds in portfolio M. Risk-return combinations beyond portfolio M can be achieved by borrowing money at the risk-free rate and investing the borrowed funds in portfolio M. What does portfolio M look like? The market portfolio. When the market is in equilibrium, portfolio M represents market portfolio. Professional investors may use market index portfolio as a proxy for the market portfolio. The line connecting risk-free rate RF and the market portfolio M is known as the capital market line. By basic knowledge from algebra, we know that the capital market line can be written as the line representation provided here. We find the capital market line has an intercept of the risk-free rate and the slope of market return minus risk-free rate divided by market risk equal to market risk premium divided by market risk, which gives us the information market price of risk. There are two types of risk inherited in each security, which are systematic risk and unsystematic risk. Unsystematic risk is diversifiable. It can be eliminated by diversifying, also known as idiosyncratic risk, non-systematic risk, non-market risk. Systematic risk is non-diversifiable. It cannot be eliminated by diversifying, also known as market risk. Now, how do investors determine rates of returns for their investment? In general, it may be determined by risk-free rate of return plus risk premium. That is, required rate of return for any risky asset is equal to risk-free rate of return plus risk premium. Now, because unsystematic risk can be diversified away, investors can only charge risk premium relative to systematic risk. Now, we cannot use standard deviation to measure systematic risk. Why? Because it does not distinguish between the diversifiable and non-diversifiable components of risk. Beta is a measure of systematic risk. It is a measure of the volatility of a security's return relative to the returns of market portfolio. Beta for security J is defined as the covariance between returns of security J and the market portfolio divided by the variance of the market portfolio. How do we interpret beta? The sign of the beta identifies the direction of movement in returns. A positive beta means the security's return move in the same direction as market return. A negative beta means the security returns move in the opposite direction from market returns. The value of beta identifies the security risk compared with the market risk. For example, a security's beta equal to 2 means the security is twice as risky as market. A security's beta equal to 1 means the security's risk is equal to that of market. A security's beta equal to 0.5 means the security is half as risky as the market. You are required to calculate the beta of the Yahoo stock. We first write down the formula and then find out the information needed to implement the formula. We have the correlation coefficient between Yahoo stock and the market portfolio, 0.8. The standard deviation of the Yahoo stock, 35%, and the standard deviation of market, 20%. We obtain the beta is equal to 1.4. In practice, we can compute beta as the slope of a regression line between periodic rates of return on the market portfolio and the periodic rates of return for security J. Without doubt, beta of a market portfolio is equal to 1. Beta of a portfolio, that is, portfolio beta, is a weighted average of the individual security betas. We can now write down security market line as the required rate of return for security J in terms of the systematic risk of security J, that is, beta J. It can be expressed as the equation shown here. The equation with the underlying assumption is known as Capital Asset Pricing Model, CAPM. It represents the equilibrium return in the capital market. For security A with beta equal to 1, the required rate of return in equilibrium should be 14.1% based on security market line. However, it now displays a return of 16%. So it is an attractive investment because the expected return is greater than the required rate of return in equilibrium. Investors would rush to buy and therefore drive down the return to the equilibrium level. Approaching from the other perspective, we can also say that security A is undervalued now. The reason is that the price of a security is determined by the present value of future expected cash flows, and currently, a higher discount rate is used to determine the present value. You can apply the similar analysis to security B. In sum, if a security's return falls above the security market line, it means the security is currently undervalued and therefore represents an attractive investment. If a security's return falls below the security market line, it means the security is currently overvalued and therefore it does not represent an attractive investment opportunity. We first calculate the required rate of return for ExxonMobil in equilibrium based on security market line. We have risk-free rate equal to 4%, beta equal to 0.65, market rate of return equal to 14%. We obtain the required rate of return for ExxonMobil in equilibrium equal to 8.55%. The expected rate of return is 11%, greater than the required rate of return 8.55%. The stock is underpriced, and the price must rise to make the required 8.55% return realistic. End of chapter question. Question number 4. You are required to find out portfolio expected return and portfolio beta. We first gather the information needed. We have beta for T-bills equal to 0, beta for General Electric equal to 1.3 given in the problem. We use security market line to calculate the expected return for T-bills and the expected return for General Electric. Portfolio beta is a weighted average of individual security betas. In this question, it is calculated by portion of funds invested in T-bills times beta for T-bills plus portion of funds invested in General Electric times beta for General Electric equal to 0.43. Portfolio expected return is the weighted average of expected return from each individual securities within the portfolio. In this question, it is calculated by portion of funds invested in T-bills times the expected return of T-bills plus portion of funds invested in General Electric times the expected return of General Electric equal to 9.81%. Question number 15. A. Portfolio expected return is calculated by portion of funds invested in Jones Trucking times expected return for Jones Trucking plus portion of funds invested in Bush Steel Mill times expected return for Bush Steel Mill. B. Portfolio standard deviation. The formula for portfolio standard deviation is given here. Plug the corresponding values from the problem into the formula. we can obtain the portfolio standard deviation. C. We first apply the security market line to calculate the required rate of return in equilibrium for Jones Trucking and Bush Steel Mill. We then compare the required rate of return in equilibrium for Jones Trucking and Bush Steel Mill with the expected return from the market. We conclude that the Bush Steel Mill is a better buy because the expected return 17% exceeds the required return in equilibrium 16.4%. Now, question number 6 is a straightforward application. Detailed solutions are provided in the slides. Let me know if you have questions.